last bit we're going to look at this section of trig, and then we'll see trig again later in the year. 3D trig. Now, 3D trig is actually an extension topic. So any problem on 3D trig, you see that in an extension exam. You shouldn't see it in a 2-net exam. So let's just go over it. Now, it can get very confusing and deceptive, the diagrams in 3 dimensions, because of the way they're trying to draw their diagrams. Sometimes you see right angles where there's not right angles and things like that. So often it's easier to redraw the different faces of the shape in 2 dimensions so you can get a feel for what the picture is doing. So we'll do it by looking at some HSC ones. Here's quite an old one now. David's in a life raft and Anna's in a cabin cruiser searching for him. They're in contact by mobile phone. David tells Anna, who's changed the way she spells her name for some reason, that he can see Mount Hope. From David's position, the mountain has a bearing of 109 degrees and angle of elevation. It's like he had all the instruments there. So when he's on the mobile phone, he can say, yeah, look, I'm a bit lost, but I do know the angle of elevation is 16 degrees and my bearing is 109. Now, Anna, she can also see Mount Hope, and fortunately she also has the instruments to tell, hey, I'm on a bearing of 139 degrees and the angle of elevation is 23 degrees from where I am. And they both happen to know that the top of Mount Hope is 1,500 metres above sea level. This is why I love a good practical problem. Maths in the real world. Okay, find the distance and the bearing of the life raft from Anna's position. Okay, so they supplied us with this beautiful diagram with the given information. So, all right, I'm going to pull out the triangles and write in the information we know. So I've got a right angle triangle HDB, 16 degrees, Mount Hope's 1,500 metres high. Then we've also got one for Anna, 15 metres high, angle's 23 degrees. Now, here we go. We were told that from David, D for David, and there's B for... What's B stand for? Oh, B is the bottom of Mount Hope, on a bearing of 109 degrees. So we know the mountain's in that sort of direction. Whereas Anna, her bearing was 139 degrees. So we want to find how far between them and the bearing of David from Anna. So it'll be that green one that I've marked in there. So I guess if we can find angle BAD, we can add it onto the 139 and we'll have the bearing. Okay, now can we get some more information on that third triangle and hopefully use a sine rule or a cosine rule or something like that. Now we've got BD is in my red triangle and BA is in my blue triangle, so I should be able to work something out there using those 2 triangles. So BD will end up being 1,500 tan 74, whatever that happens to be. And AB would end up being 1,500 tan 67. So going back to our diagram, I can label that in. I've now got 2 sides of my triangle. I want to find the third side, so it's looking like maybe a cosine rule, but I'd need to know an angle inside the triangle. So now that's 109, I know that one's 139. Okay. If I draw in another north over here at the bottom of Mount Hope, so over at B, so they're all parallel, I should be able to use some geometry here to get some angles. Okay, so NDB and DB, what I labelled N double dash, would be 180, co-interior angles with parallel lines. So playing around with that, I can get angle DBN double dash is 71 degrees. And I can do a similar thing and find ABN double dash as well. That will turn out to be 41 degrees. Now, that allows me to find angle ABD. And it should be 30 degrees. So, all right, we can now plot that in there. So we found ABN, co-interior angles. We found N double dash BD, subtracted, gave us 30 degrees. It looks like I can now use cosine rule. I've got 2 sides and an included angle. Cosine rule, there it is. B squared equals 1500 squared tan squared 67, 1500 tan squared 74, minus 2 times, etc., etc. But basically it's all calculator work from there. I end up with, to the nearest metre, 2,799. That was the first part of the question. You'll remember it also said, find the bearing. So we know how far apart they are. Let's go back to our diagram. We want to find theta. We now have all 3 sides of the triangle. We have one angle as well. I should be able to use the sine rule now to find the angle BAD. BAD. So, sine of BAD over 1500 tan 74 will be sine 30 over, well, I've written down B. 2799, remember, is an approximation. I want to use the exact value that I've got stored in my calculator from the previous question. That'll get a more accurate answer. So sine DAB, again, bit of calculator work. Now I've got 2 possibilities, remember, because we're playing with the sine rule. Is it possible this could be an obtuse angle? It's either going to be 69 degrees 9 or 110 degrees 51. Now, if angle DAB is 69.9, if I say the acute angle, which most people probably assumed it was, because the calculator came up with the acute angle and went, oh, there's my answer. But that would mean BDA would end up being 80 degrees 51. But DAB is bigger than BDA. So therefore, BDA must be the 110, 51. So what we're saying is, I know 1500 tan 74 is bigger than B, so therefore this angle must be bigger as well. So it did turn out that it's the obtuse angle that we wanted. I like to slip little ones like that there, just to see who's checking their answers and thinking about the problem. Okay, so the bearing, because we still haven't got the bearing, of course, because all we've found is angle BAD. We've got to add it on to 139 to get the bearing. So there's another little bit to go in the question. We end up finally with 249 degrees 51. 2000 gave us this particular diagram. Surveyors, they love finding heights of things. This is what they do. They survey, get their little theodolites out and check out the angles. Okay, so what's this one doing? We've got a tower, OT. Height H, angle of elevation from A is 45 degrees. But they then walk 100 metres due east to B, and the angle of elevation now becomes 30. Now, we're going to find the length of OB in terms of H. So going to draw a triangle. OB is in that particular right angle triangle. We don't know H, but it said put it in terms of H, so we don't need to know H. And we know that angle's 30. So OB over H is, well, I've said tan 60. You could have said cotan 30. Again, I tend to go with the ones that are on the calculator. So tan 60. OB is H tan 60. We now have to show that that height is 50 root 2. We have another triangle, AOT. We know that's 45. Now, ATO must be an isosceles triangle, because it's a 45 degree right angle triangle, angle sum of a triangle, well the other one must be 45 as well. So a right angle triangle, so AO is also H. And if I look at that triangle that's in the base, we know AB is 100. We just worked out in the first part that OB was H tan 60. We want to find H, which is OA. Pythagoras. Make H the subject eventually. 2h squared is 100 squared. H squared, 100 squared on 2. 100 on root 2 for H, which does simplify down to be 50 root 2. Okay. We're now going to calculate the bearing of B from the base of the tower. Okay. So there's that triangle again, OAB. A bearing of B from the base. So we place the compass at O. We want NOB. Well, I can find AOB simple right angle triangle will do that. AOB, 54, 44, that turns out to be. So the bearing must be 180 minus that, 125, 16 for a bearing. Okay, so it's in the book too, the 3D trig. So the odds, and to mix it up a bit in 2H, we'll do the evens.